Welcome back, ladies and gentlemen, for the second day of 8.1 proofs with polygon angles. Now, we're only going to do one thing today, one problem today, but I need you to be able to reproduce it yourself and perhaps expand on it or even generalize it. You'll notice that there's no question for the response form today, but there is still a response form, so I need you to still, yes, please go and fill out that response form just like you do on any other given day. Okay, the one proof that I want you to do today with me is to prove that the exterior angles theorem for polygons is true for the specific case of a hexagon. So if you don't recall, the polygon exterior angle theorem says that the exterior angles of a polygon all add up to 360 degrees no matter how many sides the shape has. So we're going to prove this, and to do so, we better make sure that we can talk about exterior angles, which means that we have to draw them in. So construct the exterior angles by extending each of the sides of the polygon around the edges. It should look like that. Notice I've also thrown in some labels, a lot of labels. There are 6 angles on the inside and 6 angles on the outside, so I have 12 labels altogether. Now, once we have the exterior angles constructed and labeled, we can also label the interior angles. And although we're trying to prove the exterior angles theorem, so I can't use that, I can use the interior angles theorem. And you'll notice that each interior angle is related to an exterior angle, like A and G are a linear pair together. So there is some relationship between the interior angles and the exterior angles. So let's hope that that pans out in algebra through an equation. So let's start trying to get this organized and write down anything that we know. And what we do know from the interior angles theorem is that if we add up A plus B plus C plus D plus E plus F, we should get the sum of the interior angles, which is n minus 2 times 180. So in this case, we have a hexagon, which is 6 sides, minus 2 would be 4, and then 4 times 180, which would be 720. So we know that the sum of the interior angles should be 180. Since we know that, let's write down an equation saying so. Add them all up. A plus B plus C plus D plus E plus F should be 720 degrees. Well, this is a good thing because we have now that the sum of a whole bunch of angles equals a number, and that's kind of what we want to prove. We want to prove that the sum of all the exterior angles equals 360 degrees. Now, I don't have any of the exterior angles in that equation, nor do I have the number 360, so it's seemingly far away. But there is a relationship between each of those interior angles and the exterior angles, which is that they are linear pairs, which means that A and G are a linear pair, therefore their measures should add up to be 180. And I don't have any G's in there, up there. I would really like to have a G up there, so if I could just rearrange this equation just a little bit so that I can substitute in for angle A, that would be awesome. And I can do that just by subtracting a G off of both sides. And then of course I could repeat that process 5 more times for each of the other exterior and interior angle pairs. And I could get 5 more little teeny tiny equations that I can then substitute back into our original. So I have 1, 2, 3, 4, 5, and 6 different equations to substitute in for each of these variables. So I'm going to take each of these little expressions right here and substitute them in. And that's what it looks like. So we have this giant long expression going on here with a whole bunch of 180s in it. And all of our exterior angles are now in our equation, which is fantastic. Now all we have to do is combine some like terms. We got a whole bunch of 180s added together, 6 of them. That'd be 1080 altogether. And we have our exterior angles represented, but they're all negative, so they're not really a sum. They're a difference. So let's turn all of those positive by adding them over onto the other side. If you do that, everything becomes positive. And I'm getting really close here because I have the sum of my exterior angles, which is represented in this portion of the equation right here. But I've got this extra 720 hanging around. You can guess that all we have to do is subtract that over to the other side. And boom, we've got 360 equals the sum of all the exterior angles. Therefore, the sum of the exterior angles is 360, and the exterior angles theorem holds true. Now, this is an important proof to be able to understand, and not only understand, but also replicate. I can now ask you to do this for any sided polygon. So any n-gon, you can repeat and replicate and expand and generalize this proof. I might even ask you to generalize it for n-sided polygon. In fact, your assignment is modified in such that I have chopped off the last bit of it, the harder problems, in exchange for 2 proofs that you have to do for me. So instead of another 5 or 6 problems, you're going to do 2 proofs for me this time, showing that the polygon exterior angle theorem is true for a pentagon, so 1 fewer sides than I just did up there, and you're going to show me that the polygon interior angle theorem is true for a hexagon. And you're going to do that through the method that we used in the previous lesson, that is chopping a shape into triangles and labeling the interior of the triangles. That's what I have for you today. Don't forget to fill out that exit form.